Alright, in this video we will examine the process of writing a linear equation that is perpendicular to another linear equation that we are given. And we're going to make that linear equation pass through 2 points. An x and a y coordinate. And I'll show that entire process and how to do all the math. This will be a fully worked solution from a homework assignment, the link to which will be in the description. So we're looking at this homework assignment here. If you can't click the link, you can just Google writing equations of parallel and perpendicular lines and then add KUTA to the end of that search string, and you'll find this little packet here, and you'll find the solutions with it as well. But in that solution set, they only give the answers, they don't show the process. So we are going to look at number 6. It says here that we are given points 4, -1, and we want to find a line passing through those 2 points which is perpendicular to this linear equation right here, y equals x plus 2. Okay, in each one of our examples, like for this one, what we need to do before we proceed is, in the equation that we are given, we need to identify m and we need to identify b. M is the slope, and this problem is good because it doesn't have a coefficient. That's the number in front of the variable. It doesn't have a coefficient for the slope that's actually printed on the page, but there actually is a coefficient for the slope hidden there invisibly, and that coefficient is 1. So m equals 1. That means when we do rise over run, that's rise 1, run 1, rise 1, run 1. If this is the coefficient for the slope, the y-intercept must be 2. So b, which is the letter we use for y-intercept, is 2. Just to touch base with the other letters here, y is the dependent variable and x is the independent variable. So now that we've identified each component of our given linear equation, let's examine the process now. The very first thing I'm going to do is graph y equals x plus 2. Once I graph y equals x plus 2, I will find the negative reciprocal of the slope. That's m superscript -1. Negative reciprocal of the slope. Once I find the negative reciprocal of the slope, I will plot point 4, -1. After I plot 4, -1, I'll use the point slope formula to find the perpendicular line, the equation of a line perpendicular to this line. And then finally, I'll graph perpendicular line. So this is our procedure for these perpendicular problems. So we're going to go through and we'll check these off as we go. So first, let's graph y equals x plus 2. So for that, we'll move to our graph paper. Given the contrast of this video, you can't see the grid lines, so I'll draw them in. They're pretty much invisible. Let's see if I can. There. Okay, so now we can see the grid lines. Remember, our equation that we're graphing is y equals x plus 2, so we need to make a y-axis. Okay, we'll label that axis y. That's the vertical axis. And then we need to label the x-axis. So here's the x-axis. Okay, we label that x, and then identify our origin point, 0, 0, right there. Now, let's graph the linear equation y equals x plus 2. In order to graph that, we need to demarcate our points. So, if I have enough space, this should work. We will use these boxes as units. So each box is 1. So here is 1, here is 2, here is 3, 4, 5, and so on. Same thing on the x-axis. Okay, here is 1, here is 2, 3, 4, 5, and so on. On the negative side of the y-axis, okay, so this is -1, -2, -3, and so on. Okay. We could plot negative numbers on the x-axis as well. -1, -2, -3, and so on. Okay? So now that we've kind of got a graph drawn, or a coordinate plane set up anyway, we will plot y equals x plus 2. So let's examine a couple of things about y equals x plus 2. Since m equals 1 and m is a positive number, I know that the incline of the line will be upward sloping. So back to our mountain. Okay, I'm going to be taking the chairlift up the mountain. I'm going to climb the mountain here. Okay, I'm going to climb the mountain. Where I start climbing the mountain, right here, the base of the mountain for this problem that we're going to graph is 2. Okay, because 2 is the y-intercept. The y-intercept is where the x-coordinate is 0 and the y-coordinate is 2. So plot that point, 0, 2. That's the y-intercept for this linear equation. We got that by looking at b, or 2. So that's b, 2. Now we use the rise over run to plot in our slope. And remember, since we have a slope of 1, we go up 1 over 1. So up 1 to the right 1. Up 1 to the right 1. Once we've plotted a couple of points, it's fairly trivial to draw in the graph. And what I'm trying to do is line up my straight edge such that every time I see one of these intersections of the grid lines, my straight edge is passing through the center. Okay, so be careful with this, and it'll look better the more time you spend getting it right. Okay, so indicate that this is a line right there, and we've already labeled it, y equals x plus 2. Now we need to go back to our work surface, or we could just move down here, or maybe over, create a little bit of space. And now we need to find, so going back to this page here, we have graphed y equals x plus 2. Now find the negative reciprocal of the slope to find the slope of the perpendicular line. So in order to find m superscript -1, what we do is we take the slope, this is equal to negative inverse slope. So if I have a slope of 1, I'm going to put 1 over the slope. So I have to plug in what I found for the slope, and m equals 1. So in this problem it's fairly simple. -1 over 1, which is just -1. Okay, so now that I've found the negative reciprocal of the slope, I can use the point slope formula to find the equation of the new perpendicular line. But according to my checklist here, first I need to check that and plot the points that we're given, 4, -1. It's not enough to find an equation of a line perpendicular to another line. That line that we're finding must pass through this coordinate right here, 4, -1. This is the x value of the coordinate, and this is the y value of the coordinate. So we're plotting 4, -1. I'll look at my graph, and I know that 4 is the x value, so starting at the origin, I go to 4. And then I go down 1 to get to -1. This is where I have 4, -1, right there. And I'll label that point 4, -1. Okay, so we'll use this as in our point slope formula, this point here. So let's use point slope formula. Let's recall that point slope formula is y minus y1 equals m, open paren, x minus x1, close paren. We actually have the y1 value, which is -1, and the x1 value, which is 4. And this is where I'm getting that data. So plug in what we have. Y minus, open paren, -1 equals, and this m value here, it might have been more helpful. For this m value, I need to actually use the inverse slope. I need to use the negative reciprocal of the slope. So that's this number right here, -1. That's m superscript minus -1. So let's plug in -1, open paren, x minus, and then look for my x value, 4. So x minus 4, close paren. Let's simplify, distribute, and solve. We want y by itself on the left, and everything over here in y equals mx plus b form. So I have y minus -1. So two negative signs become positive. That gives y plus 1 equals. Distribute the -1 through the parenthetical expression. I have -1 x, which we can just write as -x. So -x. And then -1 multiplied by -4 gives a positive number. Negative times a negative is a positive. So plus 4. Now I'm almost there. So I just need to isolate the y variable on the left side of the equal sign by subtracting 1 from both sides. Okay? 1 minus 1 is 0, so those cancel, leaving y by itself equals negative x, and then we have positive 4 minus 1, which leaves 3. So plus 3. This is the equation, y equals mx plus b, of my perpendicular line. So this is the equation of the perpendicular line. Identifying the components is also important. So m in this case, okay, equals negative 1, and b equals 3. I want to show you how to plot this in two ways.
Meeting today right now in Miss Asper.
Sorry for that interruption. So what we're going to do is plot this in two different ways. First, I'm going to start at my point. And remember, my slope is negative 1 for this perpendicular line. So rise is really fall, okay? And run is to the right. So we could do it two ways. I'll show you both ways. I could go down 1 over 1. Okay? Before we were going up 1 over 1 to the right. I could go down 1 and over to the right 1. Conversely, I could start back here at this point and I could go up 1 and then over to the left 1. Do you see it doesn't matter? I'm going to end up forming this line. So I could go up 1 and to the left 1, or I could go back to my central point and down 1 and to the right 1, down 1 to the right 1. Either way, I'm going to continue this pattern of forming this downward sloping line. And I'm just going to, for demonstration purposes, only draw in part of this for a moment, because I want to show you another way that we can do this. So let's say that now that you've got the equation of the line, you could start at the y-intercept of this perpendicular line, which is 0, 3. So let's do that, and we'll see if these two methods cohere. Let's go up to 0, 3 and put a dot right there. Now, using our slope, we can go up 1 to the left 1, or we could go back to the y-intercept and we could go down 1 to the right 1. And let's see if these lines that we're drawing in using these two methods match up. And they always should. Okay, and they do match up. Now, let's label this line y equals negative x plus 3. This is the perpendicular line. It passes through the point 4, negative 1. These perpendicular lines form a 90-degree angle with one another. Okay, just like that. Now, it's my practice and your option to highlight your lines and the equations associated with them. But that's up to you. It helps me visually and brings a little bit of color and art into the process. Okay. So let's transfer our work back to our homework page. So the equation of the perpendicular line is y equals negative x plus 3. And we'll now highlight this original line with yellow, since that's what we used on the graph. and this new perpendicular equation in pink. And that is how you solve those perpendicular problems. So now I think we've solved all the different types of problems here in this tutorial. Those of you who are still struggling with standard form, we can write this is slope-intercept form. We can write this in standard form by moving the x factor over to the left side of the equation. I'm just extending this exercise. You don't have to do this for number 6. So I have x plus y equal to 3. That's standard form for this right here, for the perpendicular line. Standard form for the original line, we were given y equals x plus 2. So we could subtract x from both sides. And now we have minus x plus y equals 2. Now sometimes books want you to get rid of the negative sign, but this is really standard form. The whole idea is ax plus by equals c, where a, b, and c are all integer values or whole numbers, no fractions, and I guess they want it to be positive. So, these are fine right here in standard form. And this is the answer to number 6. You need both the answer, the equation of the line, you need the graph like this, and you need to show your work of how you arrived at the equation of the perpendicular line. You need to show your work of how you arrived at the negative reciprocal of the slope. So all of this goes into each problem. So I hope that was helpful. Just closing out, this video showed us how to find and graph the equation of a line perpendicular to another line, and we showed not only how to graph it but derive the equation using the point slope formula, and I hope that was helpful. Please make sure to like and subscribe and leave any questions in the comment section. Thank you.